So, this is chemistry, building blocks from which all things are made. Many people think of chemistry in many ways. Breaking Bad helped at least to think about chemistry, but there are higher reasons to know so. Color and liquids associated with that, and of course there are gases and things released. Some examples. There's a new material out there called graphene, perhaps more later. Lithium-ion batteries, solar cells, supercapacitors, catalysts. There's so many interesting things that chemistry can help us understand and do. Even sand on the beach, the clouds in the air, the water in the ocean or lake. These are all molecules, and chemistry helps us understand how they're connected and how they might be utilized. The air we breathe, composed of nitrogen, oxygen, some carbon dioxide, and a few other things. We need these molecules to move in and out of our lungs every day, constantly, and these molecules are important. The food we eat, it looks attractive, it tastes good. Again, a few building blocks from chemistry assembled in interesting ways that taste good, look good, and are essential for our survival. The clothes we wear are composed of molecules organized in particular ways to produce interesting colors, textures, strength of materials, behavior under various conditions. And so, again, we see examples. Fireworks, plenty of examples. A rather old example, which bright colors, loud sounds, how big, how long, what color, all that is based on chemistry. Colognes and perfumes, they're magical fragrances, produced in interesting ways, often with natural materials found in the environment, but they can also be produced by molecules that we engineer particularly. Another application of chemistry. Medicine. Medicine saves and improves lives of humans and animals, and does so many things to help us live longer, and a lot of that is tied to the chemistry happening inside of us that leads to our beginnings and our problems. Water, what more can I say? We need it, we appreciate seeing it, we use it for recreation, a vital resource, but a single molecule. Perhaps the most common example in which chemistry's played a vast role would be the transistor. There are 5 billion in your cell phone. From the simple sand on the beach, these things can be made, and they help us make things smaller and more interesting. You and I, made of DNA, which comes from chromosomes, and we too are all about molecules organized to do particular functions that we call life. Even superheroes like Spider-Man and Iron Man need chemistry to spin their webs, to make their special suits, to propel them, to offer special properties of strength and speed. Chemistry's everywhere. Now, what is chemistry looking at it from the outside? A few building blocks organized in what seems endless ways to make all kinds of things in our environment. Materials, solutions, gases, and chemistry's everywhere. The magic part is that we only need to understand very carefully a few building blocks to accomplish great things and understand a great variety of things around us. One rule we need to keep in mind: you can't make something from nothing. So if we need something and we want to make it with chemistry, we'll need to make it from something, and one of those things that we need is energy. Energy is the capacity to do work, and as work is performed, the amount of energy is reduced in the initial form more and more until finally it's gone. So we're often concerned about how to store energy. We can store it in batteries. We can store it in the form of molecules like those found in oil, coal, and gasoline. It can be stored in plants, a form of stored sunlight. All of these are chemical storages of energy that we can use. When you look at gasoline, when we burn it, we make carbon dioxide and water, and so we can look at gasoline as a form of energy itself. And to make that, things happened in the earth over millions of years, and all we have to do is unearth it. Batteries store energy when we connect them to a device, like gasoline and other fuels in our vehicles. And when it's all used up, then what? Energy really can't be created or destroyed. We can only convert it from one form to another. And when it's in a form we don't like, we say that energy is gone. Really, it's still there. The forms of energy we don't like or know how to use easily, we say represent lost energy. Some examples: heat, electrical, light, solar, mechanical, nuclear. These are all versions of chemical energy that provides a resource that we all need. Now, whenever we charge up a battery, somewhere another source of energy is used to make that energy that we need to charge the battery with. That includes plants burning fuels to provide electricity, to run a battery charger, and so on. The great thing about gasoline is that we get it from oil, which we dig out of the ground, that just shows up. The hard part is just getting to it. Other forms of energy we can't find just lying around. And so consider a couple of facts. All of the energy used by the world for 27 years is only equal to the amount of sun that reaches the earth in one day. And wind, of course, a form of solar also. Are we running out of energy? It turns out that all the coal and natural gas in the ground is only equal to about 20 days of energy produced by sunlight. And we only know how to harness about 1% of that. Fossil fuels, a great thing to have, but one big problem is pollution, and it's a finite resource, which means soon it will be harder and harder to find, and maybe we'll run out. So many places in the world need a reliable source that's low cost for food, clothing, shelter, medicine, robots, and many kinds of technology. The periodic table is an example of how the building blocks of chemistry can be presented. They're all the different kinds of atoms that there are, and all the things that we need to make can be made from them. We actually only need about 10 or 15 of the 118 possible elements. All those represent different atoms. An atom is the smallest unit of an element. Chemistry will touch your life every day in many ways. The world needs better and smarter materials. Energy sources and storage will continue to be very important and needed everywhere. You can make a difference in the world through chemistry.